Okay, so this is sort of the part 2 of our review for our circles unit test. And the first one here, it's got a ton of angles mentioned and a ton of arc lengths mentioned, basically all the arcs and angles I could think of in this picture. And it's how many can you find. But basically the way I would approach a problem like this, even if it only asked for 2 or 3 of these, the idea here was to kind of give you the idea, or get you in the habit of trying to find everything you could find first and then worrying about what's asked for. In other words, we should be able to find pretty much every angle in this picture. So first thing I told you to scratch out this 35 because it actually contradicts the information with the 28. And I also told you that this was E, this point right here. All right, so looking at this, a key fact here that actually had to be pointed out to me, I was planning on doing some problems a different way until someone pointed out in first period, key fact that makes life a lot easier is that we have a bunch of triangles here that are formed by radii, meaning the two of the sides of the triangle are a radius. So for instance, in looking at this triangle down here, triangle AED, AE is a radius and DE is also a radius. Well, every radius of the same circle would have the same length. So that means this is like an isosceles triangle here. So if this angle is 28, then this angle over here is also 28. And then I can find this angle by adding those two angles, they're the base angles of an isosceles triangle together, and subtracting from 180. So that's going to be 28 and 28 is 56, and subtract that from 180, and you get 124. So this angle right here is 124. I'm not going to go over here and look and find that. I'm just going to keep going in this picture. Now, BD is a diameter, meaning a straight line all the way across here. Okay? So that means everything on one side of it, if I cover up the other side of it, everything on one side of it has to add up to 180. So the 124 plus this angle that used to say 35 that I scribbled out, those two have to add up to 180. 124 and 35 wouldn't add up to 180, which is why we scribbled it out. So 124 plus, and it's a 56 that adds up to 180 with that. So 56 goes right here. Now again, I have another one of those triangles here. I have BE, which is a radius, and AE, which is a radius. So this is like an isosceles, or it is an isosceles triangle as well. This is the vertex angle, the angle that's not the same. These are the two angles that would be the same. So I take 180 minus 56. That will give me 124. And I split it into two angles. That's 62 and 62. Now up here in triangle BCE, I've got the same thing going on. Excuse me. Isosceles triangle CE and BE are the same. Base angles have to be the same then. 41 and 41. Remember the base angles, first to know where the base angles are, you have to figure out where the base is. The two sides that are the same, those are called the legs. They're not the base. The side that's different, that's the base. So the base angles are found at either end of that side. So here's one and here's one. So this over here would also be 41 degrees. 41 plus 41 is 82. So I've used up 82 degrees out of 180. And if I want to find this third angle of the triangle, I can subtract 180 minus 82 degrees, and that gives me 98 degrees. Well, here we go back with BD being a diameter. That's a straight line, so everything on one side of it has to add up to 180. Okay, so all of this over here adds up to 180. So this 98 plus this angle have to add up to 180. That makes this angle right here 82. It's the vertex angle for this triangle. CE and DE have to be the same because they're both a radius. The angle where they meet is called the vertex angle. The side that's not the same is the base, and so the base angles are here and here. 180 minus 82 is 98 degrees. That's how much we have left of our triangle to split up between these two angles. 98 divided by 2 is 49. So I just found pretty much every angle I could find. So let's see. ABC. That's from here, B, C. That's two angles put together. That's the 41 and the 62 put together. So that's 103. ABD, that's 62. BEA, that's 56. Trace the angle with your pen. AED, with the name of the angle, AED. So that's this angle right here, 124. CDA, again, that's two of these angles put together. CDA is the 49 plus the 28. That's going to be 77. ADE is 28. BDC is 49. DCE is also 49. CEB is 98. DCB, that's 41 plus 49, which is 90. But remember, we already knew there was a rule that if we have a triangle in a circle where one side of the triangle is the diameter, so triangle DCB, then that has to be a right angle. Okay, so DCB is a right angle. That's 90 degrees. BCE is 41. EAB is 62. And here's the other right angle, BAD. Triangle BAD is a triangle where one side of it is a diameter. That's BD. So this angle here has to be 90, which we would also get if we added 62 plus 28. All right, now looking at the arcs, when you have central angles, these are all central angles. The central angle measure is the same as the arc measure. So for instance, this angle right here is going to be the same as this arc. This angle is the same as this arc. This angle, which is 56, is the same as this arc. This angle, same as this arc. Okay, now we can go ahead and find our arcs. AB is 56 degrees. Remember that a two-letter arc name means the shortest distance from these around the circle from between these 2 points. Arc BC is 98 degrees. Arc CD is 82 degrees. And arc DA is 124 degrees. Now we start getting into combinations of them. A to C, and I'm not going to name B because it's still a minor arc. That's less than 180. A to C is 56 plus 98, so that's 154. Now here's one that has 3 letters. We only use 3 letters when we mean a major arc. A, B, D. So that means you leave A, you go past B, and keep going in that direction until you get to D. It's kind of like when you're playing duck, duck, goose. You have to go a certain way. I'm going to pass B, but I keep going around the circle until I get to the spot where I can sit down. So ABD would be 56 plus 98 plus 82. Let's see, what's that? I'm thinking 236. If your calculator tells you otherwise, I'm sorry. BCD is a semicircle. BAC, so here's kind of like duck, duck, goose again. B is leaving its seat, passing A, and keeps going around the circle until it gets to the C position. So BAC is all of this. BA to C is 56 plus 124 plus 82. The other way you could do it is, since it includes all of this but does not include the 98, is you could take 98 away from 360 and find out that it's 262. They both give you the same answer. C, B, D. So leaving C, passing B, keep going until you get to D. So that's everything on the circle except this part over here, CD. So I'm going to take all of these and add them together, excuse me, or take 360 and subtract out the 82, which is a little easier for me. So I'm going to get 278. CDA, I would go ahead and just add these. 82 plus 124. Let's see, that's going to be 206. DBA. So leaving D, I go in the direction that I get to B first, and then past it to go to A. So DBA. D to B is a semicircle, so D to B is 180. Plus 56 is 236. And last but not least, DAC. Really? Didn't I already do this one? I sure did. DAC is the same as CBD. So it's 278. All right, next we have the segments in circles. And remember, there were two rules for this. One rule applies to both of these on the left. The rule that applies to both of these on the left is they meet inside the circle. When segments meet inside the circle like this, it's part times part of one of the segments equals part times part of the other segment. This is a very boiled down way of saying they're proportional. In other words, I look at the segment that has 5 and 8 on it, and I multiply 5 times 8. That's going to be equal to, on the segment that says 4 and x, 4 times x. So 5 times 8 equals 4 times x. This is not the same as saying this length is the same as this length. Nope, they're proportional. So 5 times 8 equals 4 times x. 5 times 8 equals 4 times x. That gives me 40 equals 4x. Divide both sides by 4, and we get x is 10. Now down below here, the two parts of this one times the 2 equals the two parts of, the two parts of this segment multiplied equals the same thing as the two parts of this segment multiplied. So 12 times 3 equals x times x. X times x equals 12 times 3. X times x is x squared. 12 times 3 is 36. What can I square to get 36? If you're not sure, you take the square root. The answer is 6. 6 times 6 equals 36. Now on this other side, the rule is a little different because these segments meet outside the circle. When segments meet outside the circle, we do outer part times the whole segment on one of them equals the outer part times the whole segment on the other one. But remember, when you have the whole segment, you have to add to get the whole segment. So the outer part of this segment is 6. The whole segment is 6 plus 10, not 6 times 10. So 6 times 6 plus 10 equals 8 times 8 plus 2x. Now over here, we don't actually have to distribute because we know how to add 6 and 10. These are like terms, so I can combine them. 6 plus 10 is 16. So I can just do 6 times 16. And I'm finally going to grab a calculator. All right. 6 times 16 is 96. Over here, you can't add 8 and 2x, so you have to distribute. That's what distributive property is for, is when you can't put these together. So that gives me 64 plus 16x. And then I subtract 64 from both sides, and that's 32 equals 16x. Divide both sides by 16, and x is 2. Next one, what's different about this one is that this segment, the outer part, is the whole thing. 10 is the outside part, and 10 is the whole thing because this segment never goes inside the circle at all. When that's true, you just multiply it times itself. You're still doing outer part times whole equals outer part times whole. It's just that on this segment, the outer part is the whole, so 10 times 10 equals 5 times the whole thing. Remember, you add 5 plus x. So this is 100 equals 5 times 5 is 25 plus 5x. Subtract 25 from both sides, and I get 75 equals 5x. Divide both sides by 5, and I get x is 15. And that's my answer for that. On to the back of this page. Oh, we've got two more still like it. And as a matter of fact, still the one on the left is they meet inside. So this is part times part equals part times part. So 26 times 6 part times part of this chord equals 12 times 2x plus 5 part times part of the other chord. 26 times 6 is 156. These I will have to distribute. 12 times 2x is 24x. 12 times 5 is 60. Now I think I will subtract 60 from both sides, and I get 96 equals 24x. Divide both sides by 24, and I believe that goes 4 times. I'm a little bit embarrassed that I used a calculator for that, but that's okay. Only because I have so many of these I do all the time. I should remember that. Okay, this one they meet outside the circle, so outer part times whole thing equals outer part times whole thing. So outer part here is 4, the whole thing is 4 plus 8. Do not multiply, add. So 4 times 4 plus 8 equals, over here the outer part is 6 and the whole thing is 6 plus x. Add, don't multiply. So 4 times, remember, if we don't need to do the distributive if we can add these, which we can. This makes 12. So 4 times 12 is 48. Distributive properties when we can't add them. I can't put 6 and x together. So this gives me 36 plus 6x. Subtract 36 from both sides, and I get 12 equals 6x. That's going to be pretty convenient because that means x equals 2. Okay, now we're done with the segment properties. The last thing we need to look at here is quadrilaterals and triangles that are inscribed in circles. Okay, inscribed means written inside or drawn inside. So we had a rule that said if you have a quadrilateral, 1, 2, 3, 4, four-sided figure that is drawn inside a circle, that the opposite angles, the corners across from each other diagonally, have to add up to 180. So what that tells me in number 7 here is that 71 plus y equals 180. Subtract 71 from both sides, and y is 109. And it also tells me that x plus 80 equals 180. Subtract 80 from both sides, and x equals 100. That's all we have to do there. Number 8. Opposite angles in a quadrilateral inscribed in a circle add to 180. So y plus 83 equals 180. And I'm afraid the custodian's about to come in with a vacuum. So if you hear that, you'll know. Y is 97. Okay, so this is 97. Now x, I'm going to do it a little bit differently here. X, I don't know the one across from it, but I do know that it's an inscribed angle, and the arc it intercepts here is 64 plus 122. So if I can add 64 and 122, which I can, and I get 206, I can take half of that, because inscribed angles, the vertex is on the circle, half of 206 is 103, so x equals 103. Okay, number 9. These two are across from each other diagonally, so they have to add up to 180. So I write this equation, and then I'm going to solve it. 4x's and 3x's together make 7x's. 9 and 3 is 12. Subtract 12 from both sides, and I get 7x equals 168. Divide everything by 7, and I get 24 for x. Okay, number 10 says find the measures of all the inscribed angles in the circle. Angle L is an inscribed angle. So that's one example. That one's already found. Let me point out that this triangle over here, triangle MNP, has one side that is the diameter. Anytime you have a triangle in a circle where one side is the diameter, it's a right triangle. And here that means the right angle is right here at N. So the measure of angle N is 90. Let's see, what else do we know? We know that this angle intercepts that 92 degrees. That's angle LNP. So it's half of 92, so that would be 47. So this is 47. So measure of angle, I'm sorry, I used an N when I really shouldn't have. That big 90, that's MNP. Let me just use 3 letters for that. MNP. I really needed 3 letters there. And then this is measure of angle LNP. That's the 47. So that means this other one up here, MNL, has to be 90 minus 47, which gives me 43. All right, let's see what else I've got. Aha, I know something I've got. If this is 47 and this is 68, look at triangle LNP. That's 2 of the 3 angles for triangle LNP. So 68 plus 47, that's 115. So this whole angle down here has to be 180 minus 115, which would be 65. So the measure of angle LPN is 65. Anything else I can find? Sure. LPN intercepts this part of the circle, the arc from L to N. So if it's 65, that's twice as big. LPN is 65, so arc LN has to be 65 times 2, which is 130. All right, the reason that helps me is that angle LNM cuts off this part of the circle, angle LNM. So if that's 43, 43 times 2 is 86. And now I can find the distance from M to N around the circle. 130 minus 86. 130 minus 86 on my calculator is 44. This is kind of a challenge problem, so don't be too worried if you're a little bit lost, but you might be able to get it still. This arc is 44. This angle MPN has to be half of that, so that's 22. Measure of angle MPN is 22. And that gives me the last angle I was worried I couldn't get. And that's this one right up here. The one at M. Because this is a right triangle, 90 here, these two have to add up to 90 as well. 90 minus 22 gives me 68. So the measure of angle PMN is 68 degrees. Wow, that drawing looks kind of messy now. All right, the last page on this we went over today. Here it is again. If you didn't write something down, if you need to see something on the key, I did show all of my work. So pause your video and you can watch it or look at it and see what I did. You will have these formulas tomorrow on your test. See you tomorrow.